Hi guys. So as you said, thanks. As Pierre David said, I will be talking about the Sednit group, which is basically a group of attackers that we have been tracking in the past year at ESET. And so basically, what are these guys? They are doing espionage. So their main goal is to steal confidential information from their victims. And they have been active since at least 2006, doing targeted attacks. And I will say that one of the particularities is that they are pretty skilled. And in particular, they develop their own malware, and they have a bunch of them, different malware. They also develop their own exploits, which is not so common even for this kind of advanced group. And in the industry, they are also known as Fancy Bear, and APT28 or SOFACI. So basically in this talk, I will first speak about the way this group infect their targets. And I will describe 4 different methods they have been using in the past and still currently using. Spear phishing emails, which is a very, very classic one, but also more originally a custom exploit kit they built to infect their target, a method they use to steal webmail credentials, and finally they trojanize some private applications to pivot in an organization. And I'm going to show you an example. And after that, I will talk about what do they do once they infect their targets and what kind of malware they use and what are they trying to achieve. So they got different malware, as I said, some for target reconnaissance, some for actual spying on the targets. And they also built a small malware just to reach physically isolated computers. So I'm going to have to describe this one also. And finally, I will give some hints on who could be behind this group. So first thing first, how do they actually infect the targets? The first method is the very classic old-school phishing method, the spear phishing in this case, so targeted phishing. And basically, here is an example. It's an email that they sent in September 2013. It's supposedly about the APEC Summit of 2013, which is an economic conference that happened in Asia at this time. And they sent this email to a list of around 50 military attachés from various countries. So you can see here Canada, France, Japan. And the text of the email says, OK, here is a list of journalists accredited for the conference. And the email has the signatures of the real person in charge of the media for the conference. So they got the name, the cell phone number is the correct one, the Twitter account is also the correct one. And in attachments, there is 2 Excel spreadsheets. The first one is actually an exploit. So if you open it in a vulnerable Excel, we get infected by the Sednit first stage backdoor. And the second one is just a decoy document. And if you open the decoy document, you will actually get a list of around 800 journalists' personal information, email, including the passport number, and their affiliation. So spear phishing is really a classic technique for targeted attacks, but in this kind of case, we can see the pretty high level of sophistication from this group because they got a decoy document which looks like a real one, and they probably stole it from somewhere. And they got the list, the email addresses of the military attaché. The exploit they use in this case is a pretty classic one, but we also observed them using zero-day exploit in spear phishing campaigns in the past. So that was the first classic infection method. The second one is much more original for targeted attacks. The Sednit group built their own exploit kit. So basically, an exploit kit is a toolkit that is hosted on internet on a server, such that a visitor visiting the website, the server, will get a suitable exploit to infect its machine with some malware. It's a very classic way for crimeware, but for targeted attacks, that's the first time we see a group doing this kind of thing. We discovered the exploit kit in September 2014. We found 3 Polish financial websites that got compromised. And basically, the attackers simply inserted 2 iframes in the HTML code of these Polish websites, such that the visitor will load the URLs in the iframe. It was the same URL on the 3 websites. The first URL on the first iframe was not responding at the time we found the compromise. But the second URL was still up. So we started investigating around this particular domain name that you can see here, defenseiq.us. And so we started just browsing defenseiq.us. And what we noticed is that we automatically got redirected to the domain name defenseiq.com, which is actually a legitimate website, a defense magazine. And it's actually, this redirection to a legitimate website is actually a classic technique for the Sednit exploit kit. They always do that. The exploit kit is hosted on certain domain name, and if you don't visit the domain name in the expected way for the operators, you get redirected to a legitimate website that looks like the domain of a Sednit group. So in our case, to get exploited, we have to visit the very specific URL they put in the iframe. So if we visit this very specific URL, what we got this time is not a redirection, but a landing page in JavaScript. So that's basically a bunch of JavaScript that will collect some information on the machine and send back a report to the web server. So you can see here an example of a report. They extract the user agent, they extract the list of the plugins installed in the browser of a visitor. It will serve to the server to give you a suitable exploit for your computer, your machine. But that's not the only thing they collect. They also collect the time zone where you are, the language of your machine, and the screen dimensions, for example. So based on that, the server will give you a suitable exploit, but only if you fit the profile of the internet targets. If they target Polish and you come from the US, you are not going to get any exploit past this step. So just to sum up, the visitor visits the landing page collects this report, and give the report to the server. The server can then decide, should the user be exploited or not, and can I exploit the user? Is it vulnerable to something? If the user is not vulnerable, it is redirected to a legitimate website. But if it is vulnerable and if we should exploit it for the user, for the operator, then they make the user download and execute a suitable exploit, which itself will download and execute the backdoor. To give you an idea of how it looks like from the network point of view, on this image, each line is a dialogue between the victim and the host. So the first line, the victim visits the landing page, gets the JavaScript landing page. Second line, the victim sends the report to the server. But third line, basically the server tells the victim, just go to this website, which is defenseiq.com, and it's the legitimate website. So the visitor was not selected for the exploitation. On the other hand, if you are selected, you got the landing page, you send your report, and on the third line, you actually are asked by the server to fetch a file, which is the exploit. In this case, it was the Internet Explorer exploit, and the exploit will then fetch on the same server the payload, the backdoor. And finally, the payload is executed on the machine, and on the last line, we see a payload poking the CNC server. So this kind of selection on the server side is classic from crimeware, again, but for targeted attacks, that's a first. And what is really, I would say, specific to targeted attacks is that they try to focus on a specific time zone, specific language, and this kind of thing. Regarding the actual exploit we observed, we have seen 3 Internet Explorer exploits that they used in the past, and very recently, actually 1 month ago, they started using Adobe Flash 0 Day that was patched 2 weeks ago. So that's another proof of the kind of technical level they have, or the money they got to buy this kind of exploit. Regarding the development of the exploit, as I said at the beginning, we got the impression that they just don't copy-paste exploits from somewhere else. They have actually some development capability. For example, at the top, you can see a development path that was forgotten in a Flash exploit. And we have never seen this path in other instances of this exploit. So it really looks like they built the exploit themselves. You can see also 2 snippets of JavaScript, which are Internet Explorer exploits. And you can see that there are some comments. There is a to-do at the bottom left. And on the right, it's a rock chain that they commented. So they seem to actually develop the thing themselves and comment and work on the thing. That being said, the way they actually most of the time redirect the victims to the exploit kit is not by the iframe in infected website. This was probably just a first test at the beginning of the exploit kit to get some traffic on the exploit kit and to test the exploit kit. Now what they do is that they come back to the spear phishing method, but instead of giving attachments in the email, they simply give a URL pointing to the exploit kit. So in this case, you can see an email that was sent last March. It was sent to a Polish official guy, and it's basically about some European Asia energy matter. And if you click on the domain name is actually mimicking the one of a real Asia news website. And if you click on it, you go on the exploit kit. Just to give you an idea, here is a list of domains that they used in the last month to host the exploit kit. And each domain is associated with a legitimate domain, as I explained. So it's the same relationship that between defenseiq.us and defenseiq.com. If you don't visit in the right way the Sednit domain, you got redirected to the legit website. And as you can see, most of these, actually all of these domains are related to geopolitics. So that gives us an idea about what kind of target they are after. That will be people that are interested in this kind of thing. So NATO, Diplomat News, and yeah, this kind of subject. So another method they use to propagate, it's not actually a method to infect people, it's a way to steal their webmail credentials. It's not technically advanced, but it's still pretty original, I think. So it works like this. Basically, a user is inside this webmail, in this organization webmail. He opens an email, which is a phishing email, and sent by the Sednit group. And most of the time, they use security conference as a theme inside the email. So there is a URL inside the email, and if you click on the URL, so the user click, there is a new window that opens inside the browser, and you arrive in front of this new domain, which is controlled by the Sednit group. And on this domain, there is a bunch of JavaScript that will do two things. The first one is to redirect the parent window, so the webmail window, the one that opened this one, to a domain that is close to the webmail domain. So the parent window got redirected to another domain belonging to the Sednit group, and that is close to the webmail original domain. The second thing that the JavaScript code do is to redirect the current window to the legitimate website of the conference. So this window will be redirected to the conference website. The user is in front of the website, so he browses the website, and at some point he comes back onto the first window, where now he's in front of a login panel of a supposedly login panel of his webmail. So he got the impression that he had just been logged out from the webmail. So he says, why not? It could happen. So he enters back its login password, click on login, and actually it's just a fake login page, of course. And by clicking on login, it's just redirected to the original webmail URL where he was actually still logged in. And the attackers just grab the login password. So regarding the implementation, just to give you an idea, there is an example they used in 2014. They were using a conference called Counter Terror Expo, and that's basically the page that is open from the webmail. So there is actually 3 snippets of JavaScript here. The first one is just a sleep function they copy-pasted from Stack Overflow. The second one is obfuscated JavaScript, which actually does this window opener location to a certain URL. That's the redirection of a parent window, the webmail window, to another URL. And finally, this code just redirects the current window to the legitimate website of the conference. So that's it for the implementation. Another example is a fake webmail login page that they used. So it was hosted on one of our servers a few weeks ago. It's a webmail for the Ministry of Internal Affairs of Georgia, which is actually accessible from internet. So they copy-pasted the code of a webmail and changed the URL inside the code and hosted it on some of their server. So that gives us an idea about what kind of target they were after. Another example is a fake Yahoo change password page that they also host on one of their servers. So they simply copy-pasted the code from the original Yahoo web page. The interesting thing is that Yahoo put a HTML comment when it generates code for a visitor, and they forgot to remove it. So at the end, there is a comment saying that actually the code was generated in April 2014. So that's the date probably where they copy-pasted the code and put it on one of their servers. So it's running for more than a year now. So that's it for the webmail. And the last method of infection that we observed in the last month from this group is also a very specific one. So here is the context. We found 2 binaries that were compiled in February 2014. And each of these binaries contain 2 things, 2 binaries actually inside. The first one is an internal application of the Ministry of Foreign Affairs of Uzbekistan that they use to manage visa demands for their citizens. The second one is a Sednit backdoor, and both are packaged inside these 2 binaries. So once you execute this package, you got the two at the same time that are executed, so the legitimate application show up, but at the same time, you got infected with the Sednit backdoor. And to give you an idea, here is the first case. It's an application called ilconsul that got executed on your machine. So as you can see, it's written in Cyrillic, and it actually connects to a URL on the Ministry of Foreign Affairs domain. So it's really a legit application. There are little doubt about that. And on the second case, this is the legit application called VisaWin. It's written Visa System in Uzbek. And that's the same thing. If you execute this package, you got this, but at the same time, you are infected. So the scenario here is probably pretty obvious, is that they got access at some point to the location where the ministry store the internal applications, because these are really not public applications. I didn't find any sign of them on the internet. They simply replaced the binaries in place with a Trojanite version containing the backdoor. After that, they have just to wait for the employees of the ministry to grab the new application, to execute it, and they infect these new guys. So it's probably a way to pivot inside an organization that they already compromised. So now what they do when they actually infect someone with these all different methods that they got. The usual process they follow is the following. There is a dropper first, and the dropper sometimes displays a decoy document to the user, to the victim. The decoy document is here to make the user believe something legit just happened. But at the same time, the dropper also decrypts and executes the first stage implant of Sednit. So basically, they have always, so the first stage is a very simple backdoor, as we're going to see, and its purpose is to collect a few information on the machine and send a small report to a CNC server, and the CNC server will decide if he wants to continue. So it can give back a binary or not. And if it gives back a binary, the first stage backdoor will simply decrypt and execute this binary and execute it. And that's really where the spying capabilities are. So I will first describe the first stage backdoor and then the second stage. So regarding the first stage, as I said, they come encrypted inside the dropper, sometimes with a decoy document that's shown at the same time. So regarding the decoy document, just to give you an idea, there is the one they used 6 months ago. It's a NATO-related press communique that they simply copy-pasted from the internet and use as a decoy. So they display the document. And another one used at the same period, also related to NATO. So these are just doc files that show up on the user side, and at the same time, they execute the actual backdoor. So the backdoor itself, the purpose for the operators of this first stage, as I said, is really to answer the question, is this an interesting machine for us? In other words, is it a real target, or is it just a malware researcher playing with us? And so that's the goal of this first stage. And to do so, they simply send to the CLT a report, as I said, containing the list of the running process, the computer name, and the version of the operating system. So there are not a lot of information inside the report, but it's actually enough, apparently, for them to decide if they want to go on. And then the binary will simply ask each 30 minutes to the CNC, do you got something for me? Do you want me to execute another binary? And I have to say that they are really suspicious. I mean, it's been really difficult for us to pass the test, probably because they know, as we see, they have already compromised a lot of organizations, so they probably know very well what a real victim looks like, a real target looks like. So you probably have to got the computer name formatted in a certain way that is the expected way in this organization. You probably have to got some process, particular process running on your machine. And if you don't fit the profile, they will never give you something. Regarding the actual implementation of a code, they take special care to be discrete on the machine. And first, regarding the network communication, one of the things they do is that each time the first stage backdoor contacts the CNC server, they try to hide this request between two legitimate requests. So each time it does a request to the CNC, it also does just before a request to google.com. So you can see here a request to google.com. It's a HTTP post with a pseudo-random looking URI. And of course, Google doesn't know anything about it, so it just answers 404 not found. But just after, there is the actual request to the Sednit CNC server. And it's always like this. They try to hide their traffic between legitimate traffic. So someone just looking around it rapidly will not see the Sednit CNC traffic. Another thing they do is that if the network request fails, they will maybe because there is a firewall running on the machine, blocking the actual request to go out. They will try to do it from inside the browser by injecting some code inside the browser. But to do it, they will just wait for a browser to open. They will not create a new process on the machine to inject the code, because creating a process is noisy. It could be catched by antivirus. So they will just wait for the user to actually browse something, and they will inject the code to do the Sednit request. And all the CNC domains they use are always mimicking software update domains. Regarding the actual binary, in the first stage backdoor, so this is really probably programmed in C, and they use basically always the same two techniques to make the detection and the analysis harder. The first technique is that all the strings are encrypted with various algorithms, and the second technique is that they don't declare statically the name of the API functions that are going to be used during the execution. They fetch these addresses at runtime. So, for example, you got a snippet here where you can see that there are calls to a certain address. Actually, at this address, there is nothing at the beginning, it's just 0, because the address will be filled dynamically. So this address will be filled by this bunch of code here, where we got a series of getProc address API call. So the purpose of getProc address is to retrieve the address of a library function. It normally takes in first parameter the name of a function that we are looking for. In this case, you can see just the beginning of encrypted string. So first, the backdoor will decrypt all the strings. You will get actually the library function names written in memory. Then they execute this snippet of code. The getProc address retrieves the address of a library function. They are fit into memory. And finally, you can rewrite your code in the disassembly with the API calls and all the string decrypted. So this is actually a very classic technique for malware, but they always do that. Another thing they do in the binary is that one of the first things they do is that they fetch a Windows system library. They open it. So it's a classic Windows library. And they fetch the actual timestamps of this binary. So the last modification time, the creation time, and etc. And every time they are going to drop a new binary on the machine, they will set the timestamps of this binary to be the same as the Windows library, just to not have a binary newly created that could raise suspicion. So yeah, something interesting I found in one specific binary 4 weeks ago. It's a first stage implant of Sednit, where basically after each API call in the binary, there is a print inside a file. And they write it into a file, and they write something like this. So you got a call to malloc, for example, then print a new line in the file, beginning with an acronym that indicates the type of API call that is logged, probably COE for control of execution. Then there is a hard-coded constant that is different for each print operation. And finally, there is the return code of the API function. So it's kind of printf debugging. And so you got a file written on the machine that is basically an execution trace of API calls based on print. The interesting thing is that they never send this file to the CNC server. So I really believe that it's the way the developer actually debugged the thing on his machine. They forgot to remove the print code from the deployed binary. And that's interesting to see, like, how do they actually debug their code. So yeah. So just to give you an idea, the second value is the hard-coded constant in the code. So it's like if you do print 1, print 2, print 3. And this value is also hard-coded, I believe, to be the thread ID, probably to debug multi-thread binary. And the last one is the error code of the API call. On Windows, 0 means success. Another thing also from 3 weeks ago, actually in the dropper, so before the first stage backdoor, in the binary dropping the backdoor, there was this function where basically there is a first call at the top that is a function that retrieves the integrity level of the current process. So on Windows, the integrity level is a measure of the trustworthiness of a process. And a process that runs at a certain integrity level cannot access objects that are at higher integrity level than its own. So they retrieve the integrity level, and by the way, binary that got downloaded from internet run at low integrity level, which is the lowest you can get. So they check if the current integrity level is low, and if it's the case, they enter a loop, And in the loop, they will execute an exploit for Windows 7 to escalate the integrity level to the system level, which is the maximum. And if it is a success, they will set the persistence of the binary for all the users on the machine, because they got the right to do that once they escalate the privilege. If it fails, so they will try 3 times the loop. If the exploit fails, it will end at the bottom left and only set the persistence for the current user on the machine for the backdoor, because they don't have the right to do that, to do more than that. The particularly interesting thing is that this thing was actually a 0-day 3 weeks ago. It has only been patched in the last Tuesday patch from last week. So that's another proof of the level of technical involvement they got. So now, if you pass the test of the first stage implants, if the operators decide that you are an interesting target, they go up to the next stage, which is the actual spying on you. These second stage implants, they call it X-Agent. So this is the name they give to the project that is behind all these spying programs. It's actually a framework to create programs, and it has been a long-running development project. We found signs of these binaries from 2006. We found the Windows, Linux, and iOS versions in the wild. And basically, X-Agent binary is a set of modules that they chose specifically for the target. And each module implements a small functionality. Then the binary also comes with several ways to communicate with the CNC server, and they can choose different ways depending on the target. Just to give you an idea, in the Windows version, there is the list of modules we found in the different binary. We don't have a lot of these binaries because, as I said, they are hard to get. And the name of the module is actually inside the binary. If you were there at the presentation yesterday on C++ reversing from Eugene, you have seen that the RTTI information gives us the name of the class. And it is developed in C++, and the RTTI information are inside the binary. So we can get the name chosen by the developer to name the module. So there is a module that is in all binary. They call it the agent kernel. Like the name implies, it's the execution manager. Then they got a remote keylogger, what they call remote keylogger, which is basically a keylogger. And they got a module to enumerate network resources, which is basically the Windows share, the other computers on the same local network. There is a module that abstracts the file system access. And there is a module that monitors all the drives of a machine and look for very specific file types based on the extension. They look for doc file, and they look for cryptographic keys. And if they found one of these files, they will extract the file and send them to the CNC server. There is also a module for which is just a remote shell. Regarding the actual communication channels, as I said, for each target, it's not necessarily the same communication channels. And it's totally, it's made in it's programmed in oriented object. So it's for the kernel, it doesn't know the actual implementation of a channel. It just knows that it wants to communicate with a CNC, and the actual implementation can be different in each binary. So we have found implementation in HTTP, implementation based on emails. So they send emails with SMTP to the CNC server, and they retrieve the emails with POP3 to receive orders. We found a binary where the actual communication channel is only by removable drives. So it's probably made for non-internet connected machines. They just drop messages on the removable drives and wait for messages coming inside from USB stick, for example. Just to give you an idea, an example of SMTP exfiltration channel we found in the wild. Basically, the code, when they want to communicate with a CNC, when they want to exfiltrate some file that they found on the machine, they will log into this SMTP server, which belongs to the Ministry of Internal Affairs of Georgia. And to log inside this SMTP server, they have a list of 4 logins, which are real email address belonging to the Ministry of Internal Affairs. And they got the password inside the binary, hard-coded. So as you can see, the password, they are probably generated by the user, like the 8 times 8. And so they log into the SMTP server using an existing employee account. Then they send an email from the particular account of the employee to an address also in the same organization that is hard-coded in the binary. And they attach the file they want to exfiltrate to the operators, which means that they got the 4 login passwords of an existing employees. They probably control they surely control the recipient email address, which probably serve as a central point to gather all the information from the infected computers inside this organization. And it also means that the binary was made specifically for this organization, and it's the only communication channel in this binary. So that's another proof about the fact that they compiled specifically for target their X-agent binary. A small snippet of the X-agent iOS version that was found 6 months ago by Trend Micro, actually. And you can see here the class, and there are many different classes, but basically they can list the installed application on the phone, geolocalize the phone, record the voice, take screenshots, and they also use the same naming. So the communication channel is called XA, probably for X-agent, HTTP channel. And they forgot to remove a development path inside the binary, so you can see the iOS project, X-agent. So there is no doubt it's the same kind of thing. Finally, the last malware I would like to talk about is a small component they built, as I said at the beginning, to reach physically isolated computers. So that's probably just a standalone version of the X-agent communication channel using removable drives. So the way it works is the following. You got two computers belonging to the same organization, and one computer A and computer B. Computer A is connected to internet, and it has already been compromised by the group. So it's under their control. On the other hand, you got computer B, which is not connected to internet and physically isolated. So there is an air gap, and it's initially clean. The idea is very simple, is that there is someone that plug in a USB stick in computer A. Then the Sednit group will infect the USB key with USB stealer, which is the name we give to this particular malware. And the infection is actually just a modification of the autorun file of the USB stick. Then someone brings the same USB stick to computer B, probably because they want to transfer some data. And computer B at this point becomes infected by USB stealer, of course, only if it is vulnerable by, only if it actually executes the autorun file, which has been patched in 2009 by Microsoft. But we can expect air-gapped computers to not be necessarily up to date, and we believe that USB stealer was used before 2009 also. So if computer B is actually infected, it will register its name on the USB stick. So the USB stealer binary got executed on B, and it actually creates a folder with a computer name on the USB stick. That will serve for the operators to know which computers can be reached with the USB stick. So then someone brings back the USB stick to computer A, and at this point the operators, they know about computer B because it has registered on the stick, and they can drop commands on the stick for computer B. You get the next step. The USB stick is coming back into computer B. The USB stealer binary see the stick, take the commands, and basically all the commands relate to file searching. So these are commands to say, okay, give me all the doc files on this machine that were modified in the last 3 days. And so the USB stealer binary execute these commands, grab the files, and put them onto the USB stick. And finally, the USB stick is brought back into computer A, where the operators can just collect the files. So it's really building a command and control channel based on USB stick. An interesting thing inside these USB stealer binaries is that they got a list of hard-coded file names that they look for on the air-gapped machine. So we found two different lists in various binaries. So we actually don't know anything about these binary names. So we can guess that, for example, the talgar.exe at the bottom right Talgar is the name of a town in Kazakhstan. So that could be some private application used in some institution that they try to grab. And if you recognize one of these file names, I will be very happy if you tell me. So last thing, just to give you a very few technical hints on who could be behind this group. As you probably guessed from the bear, so a first technical fact is the resource local ID. If you saw our flash talk yesterday, you have already heard about it. It's basically, resource local ID is a mechanism on Windows to allow developers to provide resources in different language. So on Windows, resources are the text of a menu, the text of a button, and developers can provide these resources in various languages. The interesting thing is that if you don't select a language manually in the compiler when you insert the resource, the compiler will take the language of a machine, of a developer, and put this value inside the resource ID. So that means that when someone doesn't care about it and doesn't know about it, it will be the language of this machine that is written here. As you may have guessed, 1049 that we found in many Sednit binaries. We also found a lot of binaries with English US, but there are a bunch of binaries that don't have English US. They have 1049, which is Russian. So that's the first technical fact. When you find a lot of binaries over the years with this value, it's kind of a pretty strong proof. Another thing we found in X-Agent binary is a debug path that they forgot to remove, where it's written in Cyrillic, administrator, my documents. So that's the kind of mistake they can do. Of course, this can be, it could have been forged by someone who wants to point the finger at the Russian, but given the amount of small technical proof we got over the year, it's very likely that these are Russian-speaking developers, which doesn't mean, of course, that it's Russia as a state that is behind. And if you want a more aggressive version of the attribution, you can read the FireEye report on this group. So just as a conclusion, I tried to convince you that the Sednit group is really doing long-running operation, mainly focused on geopolitics, and they are technically pretty good. They always renew themselves, in particular for the infection methods. And just some final thanks to Sébastien Duquette, I don't know if he's here, because he works with me on the exploit kit, and to the all ESET Canada team. And by the way, we are hiring. So thank you for your attention.